Let's now get ready for part 2 of our Chapter 6 lecture notes over percents and their applications. We'll now focus on application of percents from a portion formula. We'll look at defining the key elements of a portion formula, learning how to solve for one unknown if we have any portion of the key elements given. We'll then also look at how we calculate the rate of percent of decreases and the percent of increases. So when solving problems involving portion, basis, or rates, you must be given two of these elements. So if I'm given the portion, rate, base, as long as I know any two of these three, then I can solve for the missing element. For example, we're back to M&Ms. Sales of milk chocolate M&Ms are 80% of total M&M sales. So again, sales of milk chocolate M&Ms represent 80% of total M&M sales. Total M&M sales are $400,000. The question is, what are the sales of milk chocolate M&Ms? So again, three elements being the portion, the base, and the rate. We have the base, total sales, which is $400,000. We have the rate, 80%. We're trying to solve for the portion. So because we know the base and the rate, we can multiply the base times the rate, and that would give us the actual portion. Therefore, the sales of milk chocolate M&Ms would be $320,000, which represent 80% of the total sales of $400,000. Now, it says sales of peanut and other M&Ms are 20% of total M&M sales. And we know that sales of milk chocolate are $320,000, and it asks, what are the total sales of all M&Ms? So in this case, if 80% of sales are milk chocolate, then the other 20% has to be the others, because when you add those together, they must equal 100%. So again, in this case, we're trying to figure out what's going to be the actual base. The base in this case would be the milk chocolate sales, which is $320,000, which represent 80%, that's the rate, of total sales. Therefore, the base will be $400,000. So based upon what's given, if I know the portion and if I know the rate, again, I can solve for the base. If I have any two of these three elements, I can solve for the unknown. Okay? So if we know that milk chocolate sales are $320,000 of the $400,000 worth of sales, and if I'm trying to figure out in this case the percent of the peanut and other candy sales compared to the M&M sales, I would take the portion, which is $80,000. That's the sales of the other types of M&Ms. Divide that by 400,000, which is total sales. Therefore, we see that the others represent 20% of total sales. And again, that you knew already, because the M&M sales or the milk chocolate sales plus the other sales combined must equal 100%. Find the difference between amounts, such as advertising costs. To find the difference between amounts, the first step is to look at the rate, the portion, and the base. And we're going to express our answer in terms of a percentage. So we're going to divide step one, the difference between those two, by the original amount. And that would allow us to see the increase or the decrease as a percentage. For example, we have Sheila went to her local supermarket and bought a bag of M&Ms. The bag gave its weight as 18.4 ounces, which was 15% more than a regular bag. Sheila, who was a careful shopper, wanted to check and see if she was actually getting a 15% increase. So the question is, did Sheila actually get a 15% increase in her M&Ms? Let's see. So rate equals portion divided by the base. We're trying to make sure that we're getting a 15% increase. So compare the difference between the old amount and the new amount. Okay? So we're going to assume that, based on the information given, that the old amount was 16 ounces. And now the new amount is 18.4 ounces. And we're asking the question, is that an increase of 15%? So first, determine the difference between the old and the new. The difference between 18.4 and 16 is 2.4 ounces. Then divide the increase by the amount of the original, which is 16 ounces, because the original bag was 16 ounces. If you take 2.4, divide that by 16, they will give you 0.15 or 15%. Therefore, it is true that Sheila did receive a 15% increase in her M&Ms because the initial bag was 16 ounces. The new bag is 18.4 ounces, a difference of 2.4 ounces, which is a 15% increase from the original amount. Next, the increase in the price of sugar caused M&Ms to decrease the weight of each 1 pound bag of M&Ms to 12 ounces. What is the rate of percent decrease? So remember again that the original bag was 16 ounces. Now we're saying that the new bag is only going to be 12 ounces. So based upon this information, the new bag is 4 ounces less than the original bag. So if I take the 4, divide that by 16, that is going to be 0.25 as a decimal, or it gives me a 25% decrease. So because of the increase in sugar prices, M&M has decreased the weight of each pound of bag by 4 ounces, or a total of 25%. Let's look at some practice converting decimals over to percentages. If you have 6.006 as a decimal, what would that be as a percent? Well, remember to go from a decimal to a percent, move the decimal spaces over 2 spaces to the right, and add a percent sign. So 6.06 as a decimal is 600.6%. What if you have 119%? What would that be shown as a decimal? So to go from a percent to a decimal, drop the percent sign and move your decimal 2 spaces over to the left. Therefore, 119% is 1.19 as a decimal. How do I convert a fraction over to a percent? Round to the nearest tenth as a percent. So first, we're going to divide the 8 into 7, which would give you 0.875 as a decimal. To go from a decimal to a percent, we're going to move the decimal 2 spaces over to the right and add the percent sign. Therefore, 0.875 equals 87.5%. Okay? converting fractions and reducing to the lowest term. So if I have 31 2/3 as a percent, first multiply 3 times the 31, which would give you 93. Add 2 to that, that would give you 95 over 3. Then multiply times 1 over 100, and that would give us 95 over 300. You then want to ask yourself, is there a number I can divide into each of these equally in order to reduce this number? And the answer would be yes. Both of these now are divisible by 5. 5 goes to 95 19 times. 5 goes to 360 times. So now I have this in the lowest terms. 31 2/3% as a fraction is the same as 19 over 60. Solve for the portion. We're saying, what is 119% of 128.9? Again, what is 119% of 128.9? Remember, your formula for portion is the rate times the base. So if I multiply 119% times 128.9, so 119% is 1.19 as a decimal. If I multiply that times 128.9, it would give me 153.39. So what does that mean? It means that 153.39 equals 119% of 128.9. So again, if you know any two of the three, the portion, the rate, or the base, you can solve for the unknown variable. So spend some time practicing these different types of converting from fractions to decimals, from decimals to percent, solving for the unknown. You have the portion, rate, and base coming out of chapter 6. Okay? All right.